Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Voyager 1 launched in 1977. For over 45 years, it has been making headlines for revealing the most shocking and unexpected secrets in interstellar space. Not only did NASA use the spacecraft to discover the massive storm on Jupiter and rings around Saturn just a few years after its official launch, but NASA has also warned the world of Voyager 1's recent strange, impossible discovery that has scientists confused and worried. Scientists are conflicted because the information from the system that controls Voyager 1's operations in space does not align in any way with the spacecraft's recent operations. What could the impossible discovery be, and what is the way forward from it? Join us as we take a trip to outer space and find out what has been happening to our universe. Voyager 1's unexpected signals. The Voyager 1 probe has been traveling through space for 47 years since its launch. It is still exploring the regions beyond our solar system, known as interstellar space, but it has recently developed a problem that has confused the team of scientists and engineers who monitor it from Earth. Even with its age and the distance of 15 billion miles from our planet, Voyager 1 continues to function well. It can receive commands sent from NASA, carry out those commands, and collect and transmit scientific data back to Earth, but there's a particular issue with one of its key systems. And the gravity of this issue is enough to have you worried too. This system, called the Attitude Articulation and Control System, or AACS, controls the spacecraft's orientation in space. It ensures that the probe's high-gain antenna remains pointed toward Earth to send data back to NASA, but the data readouts from this system do not match what Voyager is actually doing. This means that while Voyager 1 seems to be operating correctly, the information sent back by the AACS seems random or impossible. One of the problems in dealing with this issue is the wide distance between Voyager 1 and Earth. Because Voyager is in interstellar space, it takes light or a signal 20 hours and 33 minutes to travel one way. This means sending a message to Voyager and receiving a response takes over 41 hours. Despite this delay, the team has determined that the AACS is likely still working. The system's irregular data readouts have not yet triggered a safe mode. In this protective state, only essential operations are carried out, allowing engineers to diagnose and fix problems that might threaten the spacecraft. It gets more interesting. The signal from Voyager 1 is as strong as ever, meaning that the antenna is still aimed adequately at Earth. The team of scientists and engineers is now working to figure out whether the AACS itself is generating erroneous data or if another system is causing this problem. They need to understand why the information from this instrument does not align with the spacecraft's actual operations. The team studying the Voyager 1 probe is currently trying to understand the nature of a confusing issue with the spacecraft. Until they figure out what is causing the problem, they cannot predict if it will impact Voyager's ability to collect and transmit scientific data. This uncertainty comes from a NASA release in 2022. According to Suzanne Dodd, the project manager for both Voyager 1 and 2, at NASA's Jet Propulsion Laboratory in Pasadena, California, this kind of mystery is expected at this stage of the Voyager mission. Dodd explained in a statement from the same year that the spacecraft is almost 45 years old, much longer than the mission planners initially thought they would last. She pointed out that Voyager 1 is now in interstellar space, an area filled with high radiation where no other spacecraft has ever traveled. This presents significant challenges for the engineering team working on the mission. Despite these difficulties, Dodd believes that if there is a solution to the problem with the Attitude Articulation and Control System, her team will find it. If the team cannot determine what is causing the issue, they might have to adapt to it. Dodd mentioned that they might be able to fix the problem by changing the software or using a backup hardware system if they can identify the source of the issue. Voyager has managed to stay operational by using backup systems over the years. In 2017, it used thrusters that were first employed during its encounters with planets in the 1970s. These thrusters had been inactive for 37 years, but they still worked when needed. The probes are old and generate very little power each year. Because of this, many subsystems and heaters have been shut down over time to conserve power for the most important systems and scientific instruments. While Voyager 1 is experiencing this issue, we can't praise it for one of its most historical stops, Jupiter. When Voyager 1 arrived at Jupiter in 1979, many important discoveries changed our understanding of this giant planet. First off, Voyager 1 found out that Jupiter has a ring system. Before this, scientists thought only Saturn had rings. Jupiter's rings are faint and made mostly of tiny dust particles. They are hard to see from Earth, but Voyager 1's close-up pictures revealed them clearly. Voyager 1 also studied the Great Red Spot, a massive storm on Jupiter. This storm is larger than Earth and has been raging for at least 400 years. Voyager 1's photos detailed the red spot, helping scientists learn more about its structure and behavior. The storm has strong winds, moving in opposite directions around its center, and is a very complicated weather system. Apart from the rings and the Great Red Spot, Voyager 1 also discovered many other interesting things about Jupiter. The spacecraft took pictures of Jupiter's clouds and showed that the planet has many other smaller storms, lightning, and even auroras like those on Earth. These pictures help scientists understand how Jupiter's atmosphere works and how it is similar to and different from Earth's weather systems. After it explored Jupiter, Voyager 1 continued its journey through the solar system and arrived at Saturn in 1980. This part of the mission was equally fascinating, as Voyager 1 made several eye-opening discoveries about Saturn and its moons, as well as its massive ring system. One of the most interesting findings by Voyager 1 was the discovery of new moons around Saturn. The spacecraft identified several previously unknown moons, adding to the list of Saturn's natural satellites. These moons varied in size and composition, and their discovery expanded our knowledge of Saturn's moon system. Another impressive discovery was Voyager 1's detailed study of Saturn's rings. Before Voyager 1's flyby, scientists knew Saturn had rings, but the spacecraft provided unprecedented close-up views and data about their structure and composition. Voyager 1 revealed that Saturn's rings comprise countless individual particles, ranging in size from tiny grains to large boulders. These particles orbit Saturn in a vast and intricate system of rings. Voyager 1's observations showed that Saturn's rings are not solid, but composed of numerous individual ringlets, gaps, and divisions. These features are created by the gravitational interactions between Saturn's moons and the ring particles, forming complicated and constantly changing patterns within the ring system. Voyager 1 also took stunning images of Saturn's moons, including the largest moon, Titan. These images provided valuable information into the geological features and surface characteristics of Saturn's moons, helping us know their origins and evolution. Voyager 1 didn't stop observing Jupiter and Saturn's physical features. It also took a closer look at one of each's largest moons, Europa and Enceladus, and you won't believe what it found. Jupiter and Saturn's biggest moons. These moons have caught the interest of scientists because there might be hidden oceans beneath their icy shells. Europa, one of Jupiter's biggest moons, has been on scientists' radar for a while as a place that might have a secret ocean below its frozen surface. Pictures taken by the Galileo spacecraft, which circled Jupiter from 1995 to 2003, showed some features on Europa that strongly hint at a massive ocean lurking under the ice. These features, like cracks and ridges, suggest that Jupiter's gravity and the influence of other moons might be causing some serious tectonic activity under the icy crust. The idea of an ocean beneath Europa's surface has scientists excited because where there's liquid water, there could be life. Water is super important for life as we know it. And if an ocean hides under Europa's icy shell, there could be all sorts of tiny critters swimming around. Scientists think that Europa's ocean might even have hydrothermal vents, like the ones we have at the bottom of Earth's oceans, which could provide the right conditions for tiny life forms to survive. Just like Europa, Enceladus has a secret ocean tucked away beneath its icy surface. The Cassini spacecraft, during its mission to Saturn, spotted jets of water vapor shooting out from Enceladus, suggesting that there's water hiding beneath the surface and occasionally bursting out into space. Finding those water jets on Enceladus was a big deal because they not only contain water vapor, but also some organic molecules, which are like the building blocks of life. Cassini also found evidence of hydrothermal activity on the seafloor of Enceladus, which adds to the idea that there might be a lot going on under the ice. The discovery of subsurface oceans on Europa and Enceladus has got scientists thinking about the possibility of life beyond Earth. These moons are like treasure chests of potential life in our solar system. NASA has some cool missions planned, like the Europa Clipper to go check out Europa, And they're also thinking about sending more missions to Enceladus to see what's really going on down there. These two large moons aren't all Voyager 1 has discovered about Jupiter and Saturn. In fact, NASA has also released details about more shocking information about the two planets. And it's clear Voyager 1 is pretty much just getting started with revealing Jupiter's and Saturn's secrets. We'll shut off one by one, but nothing can stop the spacecraft as it continues its journey into the vast emptiness of space. Voyager 2, Voyager 1's twin spacecraft, is also doing well in interstellar space. It is currently 12.1 billion miles or 19.5 billion kilometers from Earth. For perspective, the farthest planet from Earth, Neptune, is at most only 2.9 billion miles away. Both Voyager 1 and Voyager 2 were launched in 1977, and they have gone far beyond their initial mission of flying by planets. Today, they are the only spacecraft collecting data from interstellar space. They are providing valuable information about the heliosphere, a bubble created by the sun that stretches beyond the planets in our solar system. This data is helping scientists understand more about this distant and largely unexplored region of space. Speaking of Voyager 2, it too has made shocking discoveries since it entered interstellar space. The discovery of the sun's bubble-shaped boundary. On November 5, 2018, NASA's Voyager 2 spacecraft became the second human-made object to enter interstellar space. Scientists have now shared the first scientific information gathered from this significant event. Despite crossing the boundary of the heliosphere, this doesn't mean the probes have exited our solar system. The solar system's edge is actually at the farthest part of the Oort cloud, which consists of small objects affected by the sun's gravity. Scientists estimate that it would take Voyager about 2,300 years to reach the inner edge of the Oort cloud and about 30,000 years to pass through it completely. On November 4, 2019, 5 studies were published in the journal Nature Astronomy, detailing the findings from Voyager 2's crossing. There is a boundary where the hot solar wind from the sun meets the cold interstellar space, known as the heliopause. By comparing data from Voyager 2's instruments, mission scientists confirmed that the actual crossing date was November 5th. On this date, the solar wind particles around the spacecraft significantly decreased, indicating it had left the heliosphere, the sun's bubble-shaped boundary created by solar wind emanating from our star. The new studies confirmed that Voyager 2 truly crossed into interstellar space on November 5, 2018. This event took less than a day and happened more than 11 billion miles from the sun. As Voyager 2 moved past the heliopause, it traveled from the hot, less dense plasma of the solar wind into the cooler, denser plasma of interstellar space. This transition suggests a balance between these two regions, and scientists think that the density helps to even out the pressure differences. Voyager 1 also entered interstellar space in 2012, but its plasma instrument was damaged, so it couldn't provide complete data on its crossing. From the data gathered by both Voyager 1 and Voyager 2, scientists learned that particles from the solar wind and the interstellar wind actually mix and spill across the boundary. The interstellar wind is created by stars that explode as supernovas millions of years ago. This mixing separates the heliopause and interstellar space. Through Voyager 2's crossing, astronomers found that the heliosphere has a smooth but clear boundary between the different types of plasma. They also detected a solid interstellar magnetic field which was stronger than what Voyager 1 had detected. This magnetic field starts from stars that explode, sending out material and their magnetic fields. The way the sun interacts with interstellar space is very interesting to scientists, and here's why. When the sun releases shock waves, these waves can move through the heliopause and into the interstellar medium, causing disruptions. This is similar to how shock waves from supernovae travel through the space between stars. The early data from Voyager 2's crossing is helping scientists build a detailed picture of what happens in the space between the sun and the interstellar medium. This information is valuable because scientists think other stars have similar features. As astronomers study stars with planets around them, they can use what they learn now from Voyager 2's data to understand other star systems. By comparing Voyager 2's findings with data from Voyager 1's crossing, scientists can see similarities and differences, said Stone. These two data points from where each Voyager probe crossed into interstellar space are valuable, but scientists still hope for another interstellar probe from NASA to collect more data. To understand all of this better, You can think of the heliosphere to be more like a windsock. Astronomers want a probe that can travel along the tail created by the sun's wind, extending the solar system's boundary. This would help them gather more information about the heliosphere and its interaction with interstellar space. That isn't all Voyager 2 has discovered so far. In fact, similar to Voyager 1, it has noticed moons around Jupiter and observed one. In 1979, a small moon called Adrastea was spotted around Jupiter by Voyager 2. This was an important discovery because it was the first time we found a moon. The early data from Voyager 2's crossing is helping scientists build a detailed picture of what happens in the space between the sun and the interstellar medium. This information is valuable because scientists think other stars have similar features. As astronomers study stars with planets around them, they can use what they learn now from Voyager 2's data to understand other star systems. By comparing Voyager 2's findings with data from Voyager 1's crossing, scientists can see similarities and differences, said Stone. These two data points from where each Voyager probe crossed into interstellar space are valuable, but scientists still hope for another interstellar probe from NASA to collect more data. To understand all of this better, you can think of the heliosphere to be more like a windsock. Astronomers want a probe that can travel along the tail created by the sun's wind, extending the solar system's boundary. This would help them gather more information about the heliosphere and its interaction with interstellar space. That isn't all Voyager 2 has discovered so far. In fact, similar to Voyager 1, it has noticed moons around Jupiter and observed one. In 1979, a small moon called Adrastea was spotted around Jupiter by Voyager 2. This was an important discovery because it was the first time we found a moon using images from a spacecraft in space, not just a telescope on Earth. Adrastea got its name from Greek mythology. Adrastea was like a foster mom to Zeus, who is the same as Jupiter in Roman mythology. Adrastea is unique because it's one of the few moons in our solar system that moves around its planet in less time than the planet takes to spin once. It hangs out right on the edge of Jupiter's main ring. Scientists think it might even be the main source of stuff that makes up Jupiter's rings, but even though we looked at it with the Galileo spacecraft in the 1990s, we still don't know much about what it's made of or what it really looks like, except that it's about a certain size and it always faces the same way towards Jupiter. David Jewett and Edward Danielson were the scientists that found Adrastea. They were looking at photos taken by the Voyager 2 probe on July 8, 1979. Adrastea looked like a tiny dot in those pictures. It wasn't until 1998 that we better understood what Adrastea looks like. The Galileo spacecraft could figure out its shape, but the images it took weren't very clear. Adrastea got its name in 1983. It's named after a nymph from Greek mythology, the daughter of Zeus and his partner Ananke. In 2016, another spacecraft called Juno reached Jupiter. It has a camera called JunoCam, but its main job is to study Jupiter itself, not its moons. But if things go smoothly, Juno might still be able to take some pictures of Metis and Adrastea, although probably not very detailed ones. Adrastea is the smallest and second closest of Jupiter's inner moons. It circles Jupiter at a distance of about 129,000 kilometers, which is about 1.806 times the size of Jupiter itself. It hangs out on the outer edge of Jupiter's main ring. Its path around Jupiter isn't too shaky, with just a bit of unevenness called eccentricity, about 0.0015. Also, it's not tilted much compared to Jupiter's equator, just 0.03 degrees. Because of tidal locking, Adrastea spins at the same speed it moves around Jupiter. This means one side always faces Jupiter, like how the same side of the moon always faces Earth. Its longest side points toward Jupiter because that's the easiest way for it to stay balanced. Adrastea's orbit is smaller than Jupiter's synchronous orbit radius, which means its orbit is slowly getting closer to Jupiter over time. Eventually, it might crash into Jupiter, but if Adrastea has about the same density as another moon called Amalthea, its orbit would actually be too close to Jupiter to stay together. But since it hasn't broken apart, its orbit is still a bit further away than it should be. Voyager 1 and 2 were expected to last just 5 years initially, but surprisingly, they've been operating for 42 years. At the time, the space age was only 20, making it hard to predict that anything could last 4 decades or more. This amazing achievement is primarily because of the engineers who have decided to keep these twin spacecraft running. Now, the engineers have devised a new plan to keep Voyager 1 and 2 operational. allowing scientists to continue receiving important data from an unexplored part of space. One of the main issues is maintaining enough power to run the scientific instruments and the heaters that prevent them from freezing in the cold of deep space. Both probes are now over 11 billion miles from the sun, so the heaters are essential to keep them functioning. If there isn't enough fuel to power the thrusters that keep the probe's antennas pointed toward Earth, engineers wouldn't be able to communicate with them or receive their data. Over time, the efficiency of the power systems has decreased, and the generators now produce 40% less power than they did at launch. That's not all. The thrusters on both Voyager spacecraft are also wearing out. These thrusters release small bursts to keep the spacecraft adequately oriented, ensuring their antennas remain pointed toward Earth. Voyager 2 is about to activate a different set of thrusters, last used during its Neptune flyby in 1989. Engineers performed a similar maneuver with Voyager 1's thrusters in 2017. Voyager 2 is a priority for receiving new plans because it collects more data with an instrument not functioning on Voyager 1. As Voyager 2 uses more power, engineers decided to switch off a heater for the cosmic ray subsystem. This caused the instrument's temperature to drop to -74 degrees Fahrenheit, yet it continued to send back data. This is impressive, considering the instrument was only tested to operate at -49 degrees Fahrenheit. Even though it is still in interstellar space, scientists can still communicate with Voyager 2, though it takes about 16.5 hours for the data to travel back to Earth. With a new plan to conserve power and maintain the spacecraft's orientation, engineers expect Voyager 1 and 2 to continue sending data for at least a few more years. The information gathered by these probes has been invaluable and has contributed to the planning of NASA's Interstellar Mapping and Acceleration Probe, which is scheduled to launch this year. Despite their old age and distance from our planet, the two Voyager spacecraft are still functioning, transmitting important information about the space environment beyond our solar system. Their ability to keep going for so long shows how cleverly they were designed and how dedicated the engineers and scientists behind them are. Looking forward, there's a lot of hope for what the Voyager mission might still achieve as the spacecraft keeps traveling deeper into interstellar space. Even if they eventually lose power and stop communicating with Earth, they'll keep drifting silently, carrying a golden record with sounds and images from Earth, like a time capsule showcasing humanity's accomplishments. Although the Voyagers might one day disappear into the emptiness of space, their discoveries will live on and motivate future astronauts and scientists. These spacecrafts represent humanity's endless curiosity to reveal more secrets the universe has. What do you think Voyager 1 and 2 will find or observe next? We would love to know in the comments. If you enjoyed watching this video, don't forget to leave a like, share it with your family and friends, and subscribe to our channel so you don't miss our next updates.